It all begins with metal powder, produced through a variety of processes depending on the metal involved and the specific microstructures and properties desired. The powder arrives at the part fabricator's location in bulk containers. Alloys are produced through one of several techniques, such as pre-alloying of the elements in the molten state, diffusion bonding them during the annealing stage, or mixing them in special devices to achieve a certain degree of homogeneity. A small amount of lubricant is typically admixed with the powder to alleviate the frictional forces inherent in the process. On the press, the powder is delivered from a hopper to a mechanism called a feed shoe, which then loads a precisely measured charge of powder into the cavity of a die that has been custom designed for the specific part being produced. This die, along with other tooling members, including one or more punches and possibly any core rods used to form holes through the part, define the dimensions and shape of the finished part. Compacting presses, which come in both mechanical and hydraulic versions, with pressing forces ranging from around 15 tons to upwards of 1,600 tons, are highly sophisticated pieces of production equipment, many using computerized controls for a host of pressing motions that enable the production of very complex geometries with incredible accuracy and repeatability. As the compacted part is ejected from the die, it is shunted aside and the process is repeated. The compact has the appearance of the finished component, and its green strength, the mechanical bond between the powder particles created through pressure, is sufficient for it to be handled, whether by an automated system or by an operator's hands, as it's moved to the sintering furnace. As the parts travel through the successive zones of the sintering furnace, they are subjected to a gradually increasing temperature. This heat removes the lubricant and eventually causes the metal particles to bond on an atomic level. By the time the parts exit the furnace, they've acquired their metallurgical properties: density, strength, surface finish, and so on, as well as their final dimensions. As noted earlier, one of the strongest advantages of PM, one that makes PM the acknowledged green technology it is that it's a net shape forming process. In many cases, no further processing steps are needed after sintering before the part goes into its application. But that doesn't mean PM parts can't benefit from finishing operations when necessary. To add design features such as threads or undercuts, to enhance corrosion resistance, to improve strength and hardness, to provide a self-lubrication capability, to improve surface appearance or prepare it for plating with other metals. Like any other metal component, PM components can undergo plating, coating, deburring, welding, furnace brazing, heat treating, and steam treating. What's more, unlike parts made using other metal forming processes, PM parts can be repressed or coined, as well as sized, to densify or modify the surface shape and provide stricter dimensional control. To truly benefit from all the possibilities PM offers, part designers should consult with a PM parts fabricator right from the start of the design process. With such close cooperation, the component can be designed in the context of the assembly in which it is used, and design advantages that are unique to the PM process can be gained. Experienced PM fabricators can help guide the design process to take full advantage of PM's strengths, while helping avoid choices that could ultimately increase costs due to excessive tooling replacement, unacceptable product failure rates, or unnecessary secondary processing steps. Their intimate knowledge of tooling considerations, proper material selection, and exacting design guidelines for PM fabrication will ensure the success of your component. Every day, in some way, powder metallurgy touches your life. Look around you. No matter where you are, no matter what application you're considering, chances are PM components are already there, doing the job, achieving performance objectives, exceeding expectations. Wherever there's a tough job for a metal component to do, powder metallurgy is there. the preferred metal forming solution.